Today we will see how we could be using these bar charts for better managing our resources, and also we will be touching upon how we can use it for cost planning and monitoring. So starting with definitions of planning and scheduling, drawing upon Kipling's definition, I draw upon 6 honest serving men. Their names are what and why and when and how and where and who. And the whole process of doing the planning and going into these nitty-gritty details of identifying early start times and the logical sequence of various tasks help us better reflect and think on what and why and when and how. And it's a good communication tool. Now, very often in the literature, there are two different ways planning is contrasted with scheduling. So planning involves making decisions with the object of influencing the future. It is defined as a thinking phase, defining activities, their logical sequence, and their relationship to each other. Resources are all planning functions. Now, scheduling is a step which goes after the planning. It determines the timing of operations in the project. So the schedule will determine the specific start and completion date for the project and all the project activities. Another way to look at scheduling is to consider it as the action or doing it phase. It follows planning, consisting of the definition of the timings and dates for the beginning and end of the tasks. So in the planning phase, we could start by defining a clearly laid out work breakdown structures, and the very much like an organogram. What are our key work packages? How are they all linked together? And in the earlier stages, it could be done at a macro level. So we do not go into very micro details to allow for some abstraction, and we just plan at the higher stage, and then we could have maybe micro schedules for each component of our project. And once we know what are the key work packages, we put them into a logical order, and we develop project activity sequence or logic. So the very first step which we often do is a network diagram, which helps us see what are the arrangement. So I'm not going to be reading through all of this. It's pretty much self-explanatory. In our previous examples, we did review the PERT or program evaluation and review technique. So it is in contrast to the deterministic scheduling. So very often we are working with the time brackets. So work on any activity could take anywhere between 5 to 9 months. So in those circumstances, we take a pessimistic time and an optimistic time and the most likely time, and the CPM scheduling. So we did this example, and we learned how to convert sort of a method statement into a clearly laid out network diagram with clearly laid out relationships. And just a reminder, we did an example like this. Now, a key objective of all of this is also to help see what is the relationship between different activities. So is it a finish to start relationship, or a start to start, finish to finish, or start to finish? Again, drawing upon Kipling's statement of what and when and how and where, so it helps us see how different tasks are organized. Now, quick reflection on different types of relationship. Finish to start, it's the most common type of dependency, and examples could be: you must submit your coursework before I can mark it, so your work involved in submission should be finished before my work would start. Or you must buy computer before you can install a piece of software kit on it. The other example is a start-to-start relationship. So here we are not waiting for the activity to be finished, rather the work would commence after the preceding activity has commenced. So it is a little bit more efficient in comparison with finish to start, because it allows for some sort of a concurrency. So as soon as you get started working on the bricks on this, the bricks on the site, you can start the work. So the link is between two different activities, and very often start-to-start relationships have have got an element of flag involved. So just a reminder, we did some practice on this. So we always assume while manually scheduling a project, it starts from 0 and the duration is 2. So and the early finish would be 2. And here you can see a lag of 5, which means that the subsequent activity B would be commencing on day 7. So we did some practice, and then there is other types of relationship called start to finish. I must say not very common one, but nevertheless it is theoretically possible. So workers can start work on the site only once they have finished their induction training. You must not start work on the roof until delivery of material has been completed. Another example of start to finish. And towards the end is finish to finish relationship independency. The successor task cannot finish until the predecessor task finish. For instance, refurbishment work on 2 rooms in the Maxwell building must finish on 15th March so that students can attend the class next day. So a relationship of a finish to finish between 2 activities. Or paint work cannot be finished until you finish acquiring materials. Right, so just a recap. I'm not going into detail because we have already covered this, and we did talked about 2 different types of scheduling: the deterministic, where we are clear on number of days any activity would involve, and the probabilistic scheduling, where there is a probability. So in case of a probabilistic scheduling, we are working with 3 different types of time: the optimistic time, the pessimistic time, and the most likely time. And using a PERT formula, which is pessimistic plus 4 times most likely plus an optimistic divided by 6, we identify the most likely time, which is subsequently used. And the CPM requires only 1 time estimate per activity. This method uses a most likely time estimate. Now, we have already done through CPM, so I'm not reviewing. We also did this example where we calculated the forward pass and the backward pass, which helped us calculate the early start and the late start timings. So these were the problems from the previous problem sets, and this problem, just to remind, was that for PERT scheduling, where time brackets were given, and your challenge was to convert it into expected activity duration. So for instance, in this probabilistic scheduling problem, the contractor said that the most optimistic time is 5 weeks, but it could take up to 11 weeks, which becomes the pessimistic time, and the most likely time is 8 weeks. So using this and this formula, we have calculated the expected activity duration, which is then used for subsequent CPM and calculations. So in our previous weeks, we have highlighted the importance of Slack or float in project management. So and the concept of Slack is that its amount of time and activity can slip without causing delay. And it's important for the project manager because it represents the degree of flexibility the project manager will have in rearranging the works and resources. Project network with several near critical paths, and hence little Slack gives the project manager little flexibility in changing resources or rearranging the work. So if your project is ultra sensitive, which has been optimized to an extent that there is no float or Slack, this also means that your project has got very little flexibility in terms of management of resources. So we will be, our key focus today is the resource management. The concept is very heavily tied to the concept of float or Slack, and we will be discussing both hand in hand. Right, so some theory on the Gantt chart. I'm not revising it because I think we have covered it in detail. So these slides just serve as a refresher. Now, also, I would like to remind that we did a problem on pump house construction where we started with a method statement telling us various activities which have to be completed. Then we converted this into a network diagram, and we did early start and late start. And this subsequent task involved students to use this Gantt chart to load it with the resources. So different activities involve different types of resources. Now here in this bar chart, you can see the solid line indicate the activity which is critical, whereas other activities shown in the slightly thinner way are the non-critical. So here, once we have plotted this, we would know that the work, for instance, in the first activity is taking place in the first 4 days, and the subsequent days are essentially float days. So we can have a look at the Slack, and we can see which subcontractor is working on which days of the project. We usually use an early start for our planning. So this is good in a way that all the float is towards the end. So in case of any time delays, you can draw upon the float. But the other theoretical extreme could possibly be to schedule your project using a late start timing. So in this case, we would be availing the float upfront. Now the question would be, why would we do a schedule like this? Because this makes your project ultra sensitive. But sometimes project managers use the late start bar chart to communicate with the owners. So rather than giving clients the early start dates and having not completed, getting them worried, they would be communicating with the owners using the late start, so that even if the project gets delayed and the owner doesn't get too worried. So to communicate with different stakeholders, we may be using information differently. Now in this problem, we also saw how we could use the same bar chart for managing our resources. So different activities have got different resources attached to it. So for instance, drilling of well required 4 workers per day, which we loaded onto this Gantt chart. And then we had a bit of a resource profile, which showed that on the day one of our project, we need 19 people, and then down to 12 people in the day 4. And this is not good while dealing with our teams. We cannot hire and fire people at random. Rather, the preference would be to continue to work with the given group of people for the longest amount of time possible, and to keep them busy. So we can make use of the knowledge of a float. So for instance, here we can see there's plenty of good Slack available. So possibly using this information to get a little bit more smoother profile. So here, in this case, you can see activity 3, which was previously commencing right from the the power line activity, has slightly been delayed to reduce the resource demand in the early days and to give us a slightly better resource profile. Again, in this example, we saw that the before and after Gantt charts, where the project manager was able to save a couple of weeks from the project. And the way it was achieved was by diverting the resources from non-critical activities to the critical activities. So the dark gray activities indicate the critical activities, and to reduce the overall project duration, we have to reduce the duration of the critical path. And to do this, and the project manager has diverted 2 bricklayers. So this bracket here shows resources from activity 7 to activity 2. So rather than having 4 in the after situation, it has got 6 workers. So by reducing the overall duration of the critical path, we are able to squeeze the project duration, so which was previously around 25 weeks, to a new figure of around 22. So we have been able to knock out almost 2 weeks by squeezing the duration of our critical path, and by utilizing the float which was available here. So here in this case, in the reconfiguration, we can see the critical path has been changed. So we have studied all of this, so this just serves as a refresher. Right, so coming to the session today, the key focus is to understand what are the resource needs, understand leveling of resources, and reducing the peak demands, and better project control from resource viewpoint. Now, we have been using a critical path method, which provides an ideal opportunity to balance resources as well. And when we talk about resources, we are talking both about costs as well as the equipment or any other types of resources. Now, the knowledge of float can be used to alter start and finish dates of the activity to coincide with the time when a specific resource is available. One can balance or level out specific resources by delaying start of some activities with float, and I think this will become more clear as we do a few problems. So here you can see an example of a resource loaded bar charts or a Gantt chart. So this solid gray line indicates the duration for activity A, and we have overlaid resource requirements, which could be workers on that bar chart. So activity A requires 10 workers in week 1 and 10 in week 2, and likewise activity B has requirements of 8 workers and 8 workers and 6 workers in week 4, so on and so forth. And then we can see total resource unit requirements on a week by week basis is 10, 18, 8, 10. So in this particular example, we have got quite a few peaks and a few troughs. So ideally, we would like to avoid as much as possible in those peaks and troughs and have a more resource level. So a lot of software, project management software, make use of resource loading or resource aggregation, and all that is required of you. If you are managing a project using computing environment, is load your resources and hit the resource leveling button, and the program does the resource leveling for you. But we would like to see what are the algorithms used by the program. So we will be learning to do it manually so that we are more confident in the use of software tools. So when we talk about resource loading or resource aggregation, it reflects on it's a summation on a period by period basis of the resources required to complete all activities. Results usually shown as a histogram. Now, when we talk about resource leveling techniques delay non-critical activities by using the positive slack to reduce the peak demand. We fill in the values for the resources. And resource leveling or smoothing involves attempting to even out demands on resources by using slack, which involves delaying the non-critical activities to manage resource utilization. Now here in this particular example, you can see a resource histogram where 3 types of resources attached to different types of activities are shown. So the first is resource requirement for activities on the critical path, which are shown in this solid pattern. Now these are resources attached to the critical path, and there's nothing much project manager could do other than just ensuring that those resources are available, because as these are the resources associated with critical path, it is very important that these resources are available as and when needed to ensure that project get delivered on time, because if you delay any activity on the critical path, your project subsequently gets delayed. Now the solid line on the top indicates resource requirements based on the early start timings. So here you can see if we decide to work on our project on an early start time, we have got a huge peak starting in middle of the second week, and which continues up to the middle of the 5th week, and then there is a bit of a trough. The other option of scheduling this project would have been to schedule this project on a late start time, which is giving us a resource profile indicated by the dotted line over here. And by the looks of it, if we schedule our project on late start time, we end up with a much more smoother resource profile. So, and some food for thought, and maybe in this case, to achieve a better resource profile, it may be better to schedule using the late start times. Now, we explored in the class that different clients have got different requirements. So this was an iconic project, Burj Al Dubai. Now, for this client, when they set out their specifications, it was just a one-line specification. Now, we want a building which was never constructed before and which could never be constructed again. So for this client, the time and resource constraint was not such a major issue. They were after an iconic building. But very often when we manage projects, we are working with different types of constraints. So the most common is an example of a time constraint project where a project must be completed by an imposed date. Time is fixed, resources are flexible. So additional resources may be required to ensure project meets the schedule. So an example could be a shopping center which wants to open well ahead of the Christmas season so that it could target the Christmas market. So and this is could be an example of a time constraint project. The other constraint which we may come across is the resource constraint, which is a project in which the level of resources available cannot be exceeded. Resources are fixed, time is flexible, inadequate resources will delay the project. And the other types of constraint could be physical. So for instance, on the site, your space could be limited. If it's a ceiling work, you cannot allocate it to too many contractors working simultaneously. It could be quality management or health and safety concerns. So physical constraints are another. Now we will start our discussion by looking at the time constraint resource leveling. So a project that must be completed by an imposed date requires the use of leveling techniques that focus on the balancing or smoothing resources and demands by using positive slack to manage resource utilization. So the technique used is when the peak resource demands are reduced, resources over the life of the project are reduced, and fluctuation in resource demand is minimized. So we will do a few problems. I think we have done this as one of the previous problem sets. So here it was an example. So let's assume that you're working in a project where you just can have 3 backhoes available. So if we draw a resource histogram, so on the top is a bar chart. So you can see that initially we require 2 backhoes, which is fine. And then starting from here, we require 4 backhoes, and followed by only 1 backhoe required here, and then 3 at this stage. Now, as our constraint is 3 backhoes, that means that we are using too many resources in this. So the easiest way could have been to make use of the float over here. And for instance, we may decide to postpone this activity. And if we could postpone, for instance, irrigation activity by 3 weeks, it would mean that we get rid of this resource excessive usage, and we would have a resource profile like this. So this was one example. If you are working with the 2 backhoes, for instance, only, we could manage this time period. But I think we may get into a problem because we would be requiring more than 2. So if we are just constrained with 2 backhoes, this means that we may not be able to deliver this project in 24 weeks, and the project deadline may be exceeded. So that would be a natural reaction. If our resources are constrained, and we may have to compromise our time dimension. Resource constraint projects, the scheduling of activities require the use of heuristics or rules of thumbs that focus on minimum slack, smallest least duration, or lowest activity identification number. So if you are having resource conflicts in your project and you have to decide which activity has to be prioritized, so the algorithms various project management software tools use are: number 1, use and they prioritize activities with minimum slack. Secondly, the smallest or least duration, and thirdly, the lowest activity identification number. And a parallel method is used to apply the heuristics. Parallel method is an iterative process that starts at the first time period of the project and schedules period by period any activities scheduled to start using the 3 priority rules as defined above. So let's do a problem. So some of the challenges which we may encounter is, firstly, as we start to level our resources, could be a loss of flexibility that occurs from reducing the slack. So basically we are eating into the slack, so the project is becoming more sensitive and more critical. Secondly, increase in all the criticality of all activities, so all the activities eventually become critical and they could not be delayed. And software use activities with more slack to level project resources. Okay, so I think we have done that. So in this example of managing a project using a parallel method, uh, now here the critical path calculations have been done for you. So we always assume project starts on day 0 and we add the duration to have early start and early finish and so on and so forth. We have discussed it previously. Now for the early start, we know that the early start is shown here. So for activity A, the early start time is 0. For activity B, the early start time is 2. And for activity C, the early start time is 2 again. And over here, we are inserting the late finish. So the late finish time for activity A is 2, activity B is 5, and activity C is 5 as well. So we can compute it like this. The slack information is available in the middle boxes. So for activity A, it's a 0, which is indicating A is a critical activity and should not be delayed. Activity B has got a healthy float of 2 weeks, and activity C has got a float of 0, and so on. And we will complete. Right, so let's start loading resources onto the bar chart. So here the constraint was that all we can have is availability of 2 resources, and the resources are shown in this column over here. So activity A requires 2 resources and it is taking place in the first 2 weeks of the project. So we would need maybe 2 excavators if that's the resource we are talking about in the week 2. So we have loaded resources onto our bar chart. So far, so good. Now, activity B would begin after A has finished. So B would start from here and C would start from this point onward. Activity B, it requires 2 resources and it is a 1-day activity. So B is taking place here, and activity C requires 2 resources over a period of 3 weeks. Now here we obviously have a resource conflict because the total resource requirements after week 2 is 4 excavators. We cannot have 4 anymore. So we have to make a decision which activity to prioritize. So the rule or the heuristic suggests that we have to prioritize an activity with minimum slack. So if we check, the slack of activity B was 2 and the slack for activity C was 0. So the C has to be prioritized and the work on B would take place afterwards. So here in this completed example, you can see we have decided to work on C, and once C has been completed, we would begin work on work package B, and afterwards we can work on activity D, which is just a 1 week activity. Once we have done that, completed activity D, we can begin in principle work on activity E or F. Now here, one thing to note here was that previously activity E was, the early start time was 7. But now because of the delays which have been introduced, it may not be possible to have those early start times. So we have to see which activities would we prioritize, because activity E requires 2 resources and activity F requires 1 resource. Now, we always choose the give preference to the activities having a minimum slack, which in this case is activity E. So we have decided to work on E first, and once E has been completed, then we have a choice whether to start work on G or F. But to do that, we have to recalculate the early start time. So F in a changed circumstance is not, the early start time is no longer 6, it has become 9. And likewise for G, as well it has. So while calculating the slack, we have to use the new early start time and not the one which was at the early stages. So based on this, the slack appears very lower, and we would be deciding to work on activity F first, and then this would be followed by the work on activity G, and towards the end we have got a milestone activity H, which doesn't require any resource. So in this example, we learned that wherever there is a resource conflict, where we are using more resources than are available, we would be prioritizing the activities using this formula, which is first give preference to the activity with minimum slack. Secondly, if there is a tie, then you have to give preference to an activity with smallest duration. So a lot of software tools will be using these algorithms, but it's always good to know what goes behind those tools. Okay, now another activity which is used to manage and reduce our resource imbalance is includes rearranging the activities. So you can think of a resource histogram as sort of a Lego bricks lying together. And our key preference is to reduce the overall project duration. So this project has been completed in a 14 months period, but you can see there is a big trough here in activity C. So there may be a consideration that if theoretically possible for us to split activity C, and if we can move this chunk of activity from here or to maybe over here, we may be able to squeeze the overall project duration. So here the decision is taken to split activity C into two small components. So for the first section being delivered here and the second one delivered parallel to activity E, the impact is it is having is that overall reduction of 2 weeks in the project duration. So splitting an activity could again be seen as an project cost time reduction strategy. But we should not be under an assumption that splitting doesn't come without any waste. So splitting is a scheduling technique used to get a better project schedule and or increase the resource utilization. It involves interrupting work on an activity to employ the resources on another activity, then returning the resource to finish the interrupted work. Is feasible when startup and shutdown costs are low. Is considered the major reason why project fails to meet the schedule. So I think one important thing for us to remember is that splitting is not simply like a cutting a big block into three different components. There are always shutdown and startup costs involved in any activity. So the overall project duration for this work package could perhaps be increased by a certain degree by splitting an activity. So the example of a shutdown and startup is that, for instance, your work requires use of a Caterpillar machine. So you have to bring the Caterpillar machine on site, and once you have finished the work, you may have to return it, and you have to mobilize the resources again, so causing some inefficiencies. So again, splitting and multitasking is a good option, but it has to be carefully used. Now this problem again reinforces the parallel or heuristics method of resource management, which was discussed in question 1. So the network logic has been done, and based on this, the forward pass and the backward pass calculations have been computed. Now, in this particular problem, the constraint is that we cannot have any more than 3 engineers working for us at any given time. And the resources, as you can see here, are shown in the box at the middle. So activity 1 requires 2 engineers, activity 2 requires 2 engineers, and activity 3 requires 2 engineers. So we start by plotting a bar chart, and then we start loading our resources onto this bar chart. And one thing which has become obvious is that we have got a resource conflict starting from the week 3 of the project. So there's no problem with the first 2 weeks because we require just 2 engineers, and it is within our 3 engineer constraint. So we have to decide here which activity to delay. Now, activity 3 obviously is a critical activity with no slack at all. So this has to be delivered. But activity 4 has got some slack and activity 2 has got some slack. So we have to make a decision which activity shall we prioritize. So the slack of activity 2 is shown here as 2, whereas slack of activity 4 is shown as having a 6. So 2 is lesser than 6, so which means activity 2. Uh, uh, okay, now there was another issue here, and uh, the conflict was not caused by activity 4 because it just requires one worker, so it can go hand in hand with activity 3. So we will have to move activity 2 after having completed activity 3. So we have decided to postpone work on this activity, which has resulted in a change in the early start times for activity 2 as well. So now this activity cannot begin as decided. And we will postpone the beginning of activity 2, and you can see again there was a bit of a conflict with activity 2 and 5 taking place at the same time, leading to resource peak. So we have decided to delay activity 5 so that it happens after, so that we are falling in line with the required resource requirements. So this way we have demonstrated how we can make use of uh, the project. Okay, so now let's see the let's have a quick preview through our problems as well. So let me right. So another resource management problem given to students was this dam diversion project. So in this project, the scenario was that table below gives activities involved in the first phase of the construction of an earth dam. The duration, predecessors, and the budget cost of the activities are listed. The project has a physical constraint. Because of the low flow, the river must be diverted, which is the activity H, which is a milestone activity, in the January of the next year. So let's assume we have to divert this river in January 2019. And the question was, when should we start work on this project? So to do this, the simple task required was for you to do a simple CPM method to calculate the overall duration. So this calculation has basically given us that this project is going to take 32 weeks to complete. And we know there are 52 weeks in a year. So 52 take away 30 and 32, which gives us around the 20th week, which may be around May time. So we will make a suggestion that this project should start in the beginning of May, so that we have got enough time so that the dam could be completed before January. The other question asked was that if there is, so let me open the question again. So the question asked was, assume that the project starts on the date chosen in the above, but the contractor encounters the unexpected ground conditions during construction. This results in the increase in the duration required to drive the diversion tunnel, which is activity B and D, by 25%. So how can the contractor deal with this situation to achieve? So in this situation, we are talking about that we started work, but this activity B and activity D had to face certain time delays, and as a result, activity B could not be completed in 6, but with a 25%. So this will be 7.5, whereas this activity, which was previously taking 12, would now take 15 weeks. Now we see that this activity is the critical activity. So when we talk about crashing an activity, it is important to remember that we should be crashing activities only lying on the critical path, because crashing an activity on a non-critical path is not going to have any impact on the overall project duration. So here, if we come across this situation where we have a major project delay in one of the critical activities, the best course of action would be to speak to the contractor C and see if they could knock down some of the timings from their work. Now, in this session, we will also be covering a little bit on crashing a project or project acceleration. And again, this concept is tied to the resource management. The more resources expanded, the faster the project is to finish. So very often we have to reduce the project duration or crash the project, and there could be a number of different reasons for it. So it could be because of client requirements or political pressures. Sometimes when we are planning because of political reasons or whatever, these plans are very optimistic, but they are not possible to deliver. So it could be political reasons, or sometimes there are contract commitments. There are contractual late penalty clauses, and to avoid those, we may like to have our subcontractors working in two shifts so that we could deliver our projects on time, or there could be some time to market pressures. Very often the supermarkets would like to open to tap into the Christmas shoppers, for instance, or there could be incentive contracts such as bonuses for early completions or unforeseen delays. So there could be a whole host of reasons why we would need to crash our project or reduce. Now here a question is asked on if this is the network diagram of our project and you have an ability to crash activity B and H by up to 2 weeks, which one would you choose? So you have got a situation where you either reduce activity H by 2 weeks or activity B by 2 weeks. Which activity shall we reduce? One thing which we have just discussed is that when we talk about reducing the duration of an activity, the only best thing is to reduce it on the critical path. If you have reduced duration of a non-critical activity, it is going to have no impact at all on overall project duration. So coming across these two options, we can see activity B is obviously a non-critical activity. It has got some float, so there is no point at all. We could to crash this activity, we could easily have used the float. So activity H is a critical activity. It's lying on a critical path, and if we have an option, we must select activity H and not activity B. So in the crash analysis steps, we follow certain protocol of crashing, and we list number of days each task may be reduced, list costs of reducing the task one by one. So I think it's better done through a bit of practice. So in this given problem, the challenge is to help your client find out the lowest cost and time to finish this project. So in the table below, you will find the two activity times and two costs specified for each activity. The first is referred to as a normal, and the second set is referred to as a crash time. So normal time is the normal time a contractor will take to do a job in a normal 5 days a week and 8-hour shift patterns. But sometimes it may be possible to bring in an extra subcontractor, or maybe asking the subcontractor to employ their laborers for 2 shifts, for instance. Now, very often that would involve extra cost as well. So here you are given the possibility that activity B could be completed in 3 weeks or 3 months, and it would cost 150,000 working normally, but you can reduce it by 2 months, and this should be crash cost per month, and the crash cost per month will be uh, is the one which is shown here. So first of all, we start by looking at what is the normal time to complete this project, and to calculate the normal time, we see which path is critical. So the path at the bottom is 4, 8, 3, 11, has a duration of 12 weeks to complete, and the path at the top has a 6, 9, and 10 weeks. So we always say that the longest path of the network is the critical path. So the ACEF is the longest path. So the question is, how the normal time to complete this project is 12 weeks, and the total direct cost to complete this project is shown over here. So if we do a summation of all of this, that will give us the normal time. So let's do this thing. 6, 9, and 1000. So the normal cost to deliver this project is 1000 K. Right, so if we want to crash this, we will like to explore if we could reduce this from 12 to 11. And the only way to do this would be to target an activity lying on the critical path, because the path at the top was non-critical. So we will have to see whether A, C, E, and F could be crashed. A cannot be crashed because it has X written to it, which means that this activity is not crashable. Now the question is which activity to choose. Now here we have been given the crash cost, and we know that activity C can be crashed by 1 day and 1 week, and the cost is extra 50, and activity E can be crashed by 2 weeks, and per month would be 70, and activity 1 can be crashed by 1 week with the cost of 90. So I think by the looks of it, the crashing activity C provides the best value for money. So that's what we decide. So if we crash activity C, now C can be crashed by 1 week, and it involves 50. That would mean that the time for activity C would go down from 4 months to 3 months, and I have put an X with it, which means that this activity can no longer be crashed, because the table suggests that this activity can be crashed only once. So all the other information remains the same except these differences. E would remain 4, F would remain 3, B would remain 3, and D would remain 3. Sorry, E should be 4. So the by crashing activity 11, sorry, activity C, we have added an extra cost of 50,000. So the new direct cost of our project is now 1050, and the activities changed has been C. So after having done this change, we will recalculate the critical path, and the path at the bottom here now indicates the duration of the path at the top is 10 weeks, and the path at the bottom has 11. So again, the path at the bottom is the critical path. So we have got two options now to crash, either E or F, because C and A cannot be crashed. So we will be doing this thing. So we have to repeat these steps till we get to a point where our critical path can no longer be crashed, which will provide us with the optimal time. So while working with this, and we there are two different types of times which we discussed. So one is the normal activity time, which is involves the normal delivery of work, and the other one is the crashing activity time, which involves delivering the project in a shorter duration. And the cost associated with normal activity is referred to as the normal time, and the crash costs are referred to as this. Now, based on this, we can make our decisions. So while making a decision, it is very important to not merely take decisions based on the direct costs. The indirect costs have to be taken into account as well. So with the direct costs, we can see that as the normal way of delivering a project is slightly cheaper, but as you go about accelerating the projects, the cost becomes high. In terms of the indirect cost, the relationship is an inverse relationship with the time. So the longer you spend on time, the more indirect cost you would incur, and if you spend lesser, then you can incur less. So the time cost trade-off decisions are usually taken based on a summation of the direct and the indirect costs. Okay, so this we learn about how we could use this knowledge and for better scheduling. So in the problem which we were discussing, crashing the problem, we did see that this is the final outcome. So if we have got a few options on the table, we can deliver this project either in a 12 months duration, which would give us a direct cost of 1,000 and the indirect cost of 1,000. So the indirect costs are being provided to us by our QS or the estimators, whereas the direct costs are uh, taken from the previous problem which was discussed. So one option is to deliver this project with a total cost of 2,000 in 12 months period, or deliver it in 11 months period, and the overall cost would be around 1175, which looks like slightly lower. So we plot these costs to have an overall view of what would be the best possible option for our customers. So a question asked here is, how does resource scheduling reduce the flexibility in the managing of the projects? So as we saw in our previous resource leveling examples, computer routines use Slack to get an efficient schedule. When the Slack has been used up, flexibility is lost and the risk of delaying the project increases. If the resource conflict occurs on the critical path, the project could be delayed. One question asked in the class was, give certain reasons why scheduling resources is important. There could be a number of different reasons, such as to check against if resources are adequate and available, decide which resources will have the priority, assess the impact if another project is added to the pool, or determine where the real critical path is, and to explore any unforeseen dependencies. So it's very important to not only schedule our time, but schedule our key resources as well. So when we go, we have a clear idea. Now, in the question 5, we did ask students to go through a bit of a case study. So here is the case study. So the question asked was that you are involved in a high-risk construction scheme and have been made in charge of a large excavation project. After meeting with your management team, you have developed a schedule below. The letters represent areas of the project to be excavated. So you cannot, for instance, work on the area Y unless the previous constraints, which is completion of area K and B, have been completed. So a typical finish to start relationship. You are confident in durations and logic. However, project has got a few constraints. One of the constraints was that you cannot have any more than 10 D8 caterpillars available for this project. So you are constrained by equipment on one hand, and you have been asked to produce a cost-loaded Gantt chart for your construction managers and for your subcontractors and owners, right? So I just want to remind students that you are not expected to be doing every single thing in detail. So the expectation was in this problem set, as far as you do 4 problems and demonstrate your knowledge of the 4 problems, that should be enough. So you do not worry too much, just focus on trying to understand what are the key concepts. So the first issue which was highlighted in this was that how do you convert your time and resource information into a Gantt chart. And we, in this problem, we converted it and we indicated the activities and the float required for different activities. So here you can see B is a critical activity with no float, and W is a critical again as well, and activity Y is critical as well. Now it was highlighted that we do not need to share this information of the float with our subcontractors. That may make them perhaps a bit lazy. So when exchanging information with the subcontractors, we may just remove the float information, which is good for the site manager or construction manager to know. But for the subcontractor, when the information is exchanged with them, all they are told is the time they have to be on the site and when they do need to leave the site for the subsequent contractors. And likewise, when we are communicating the same bar chart with the owners, we need not communicate the early start times. Perhaps we could give them the late start times, so that even if the project get delayed by any unfortunate unforeseen events, then again we have got some ability to accommodate. So once we have the bar chart, then we can load it with our resources. So in this example, the resource was the cost information. So the cost information has been given in the problem. So for instance, the activity W has got a total budget of 45,000 with the split of 22.5 per month. And likewise, activity K has a total budget of 12,000 as given in the problem, and activity B has a budget of 48,000 per month. So once we have done this, we will be producing two values. So one is the total spend. So here you can see the total spend in the week 4 is 132.1 and 132.1, and then rising to 141.6. And the cumulative is essentially a cumulative spend at any given point. So we add these two values to have the subsequent values. So 45 add 96.7. Sorry, 141 add 132 would give you 273, and 273 add 132 would give you 405. So this is useful to plot S curves or the progress curves. Right, so having a look at it in this problem, the challenge was that we cannot have any more than 110,000 spent, and the problem here, it could be seen in these months over here, where we have got a spend which is much more than expected. So the question was, how do we tackle this challenge? So here you can see the resource are being required by these activities, and we cannot move activity B because it is critical, but activity P has got some float, and activity F has got some float available. So we have to make use of this to reduce our peak resource demand. So here the decision is taken to delay the start of activity F, which has going to have a subsequent impact on activity O as well. So by delaying the start, we have tried to bring the resource profile back to the boundary which has been given to us. And then students were encouraged to think that we could use the information of the cost spent to draw our project progress curves. I think we will be discussing these in the project monitoring and control lecture in more detail, but we could plot our project S curve based on the early dates and the late dates, and these are also called banana curves. And the focus during the project management execution is to ensure that the actual progress remains within this curve. So in this problem, we learned that how we could use Gantt chart as an effective communication tool and transfer the information and exchange information which is appropriate. So not sharing too much information or not sharing too little information. Now this is unfortunate to say, but very often the projects are delivered not in the best team-centric manner. So perhaps there is no point for construction managers sharing all the information about the float with the subcontractors because of this different conflict of interest. So very similar to this problem, and the last problem asked students to do a little bit more practice in a again a cost loading and equipment loading problem. So here the calculations have been done for you, indicating the critical path which is running through B, F, K, F, G, and C. So the first challenge given was to develop a cost-loaded bar chart for project manager, including the cost histogram. So basically, we have loaded our costs onto the bar chart, and here you can see the cost spend, and no constraint has been given here. So uh, this is how the cost profile is looking like. This information can be exchanged with the owners in advance, so that the progress payments could be agreed in advance. And using the early start and the early finish time, we could plot the project as curves. Students were asked to do a little bit practice in for the similar concepts using the equipment. So the challenge given here was that certain activities require certain amount of equipment. So plotting those equipment, the students could produce resource. This particular example, no constraint as such was given, so that's fine. But if you have been given a constraint, then you can manage it accordingly. Okay, so I think um, that's what we wanted to cover in our session today, to uh, learn a little bit about. So let's go back to the problems which we have discussed. So the slides are available from the session, but the first two problems helped us learn more about the parallel method and how the computing and software project management software tool do the resource leveling. And question three again talked about how we could effectively plan from the key milestone dates backward. Question four, we experimented with the crashing of the project, so how we could reduce the overall project duration and how we could identify the ideal or optimal time quality curve. And the question five and question six essentially focused on use of bar charts as a tool to improve the resource management, and then addressing different sort of a resource constraints. So for instance, the cost constraints under different situations. Okay, so I think that's pretty much all that I want to talk about. I will like to leave some time for you to practice. The solution has been posted online, and the copy of the presentation. So most of these solutions are here. So as we said in our initial class, the best way to learn about planning and scheduling a project is not just by listening to the lecturer. It does involve you doing a little bit of a practice. So I think perhaps this time could be used to do a little bit of a hands-on on this. Uh, so the all you have to do is go on the module website and download the problem set from there, and then you can practice different problems. So as far as you can do the 4 problems, and that is all what is required. Now, can I ask, are there any questions at this stage? So I got a message from a student who was very worried about the problem sets. So mind you, we will be providing the support. I have asked students to post their solutions. So for instance, if any distance learner is struggling, they could look into those. So the key objective of the problem sets was that you need to be good in terms of manually planning and scheduling a project. You need to know the basics of critical path method. How do we use critical path method for planning our cost and time? Okay, now the expectation will be right. So then I will show you how you can access the modules on the module website. If you are not registered on the module site, then that is the issue which has to be taken with Nikki and Harry. Yes, Simon, and the objective was to allow enough time for you to practice as well. So I think you can give it a go. So I will like to go through uh, the module side for those of you who are struggling to get into. So this is the module website. Now, first, registered to project and production management inbuilt environment 1718. Now, Dan, I got an impression you have not got an access to this. So if this is the case, your first point of contact is okay. Uh, right. So it means that you have got access to the module site. So what you would do is go to the module site, and then you will have to choose the uh, uh, learning materials. Once inside the learning materials, you will have full-time students. So for instance, if we go to week 1 and 2, you would be able to see the problem sets of week 1 and week 2 over here. And today we are talking about week 4 lecture. So if you click on this problem set 3, you should have access to this problems which we just discussed. So the lecture recording will be available. You can give it a go and maybe compare it. And also you can refer to the class presentation and so you can have uh, access to it. Also, there are learning packages which provide a little bit more background reading. So project constraints and assessment go hand in hand with our discussion today. And also uh, this co-reading text, and if you read through the construction management, which is a huge document, and within that there is a section on resource management, chapter 13, which will delve in more detail the concepts which we have covered. So if you to have some theoretical background, you may consider reading through those resources. But I would emphasize again that it is important for you to take a little bit of a time to do practically solve the problem to give you the confidence. Okay, Simon, you are right. And now in the assessment section, a few sample submissions were made available from the previous. I think there is an access issue. It has been highlighted, and I am going to correct it. So you should have some of the previous submissions which you can uh, look into, some examples of the lower grade and the higher grade. So talking about the coursework, the expectation was that you would be reviewing a project that you are familiar with. It is an exercise in the critical review where you have to demonstrate some awareness of the key industry trends and a little bit demonstration of where you see industry heading in next 5-10 years, how it would possibly improve project management. Now, a lot of time, key challenges in project management relates to poor communication, poor coordination, lack of clarity, and things of those sort. So how you see emergence of new trends of the sort of virtual reality, augmented reality, artificial intelligence, Internet of Things could positively influence our management of projects and things of that sort. So part of it would involve looking forward as well, and part of it would be a descriptive and critical overview of what went wrong, what went. So I think you have to demonstrate you had a chance to critically look at the given case study, and at the same time to demonstrate your good vision as well, which could be demonstrated by reading some good literature and academic studies. Okay, so